Here we are at example 3 from our 2.1 number 2 set of notes. So just to recap, the average velocities eventually become the instantaneous velocity when you are at that specific target point. As you can see here, it looks like this target point is 2 that we're trying to approach. So when we get closer and closer, finding all these different secant slopes, and then finally reaching that particular target point of 2, it becomes that tangent slope, which then becomes that instantaneous velocity that we're hoping for. Now we're going to go ahead and shift gears into some of the other graphs and some of their properties. So for example, just dealing with some velocities in their graphs, if we had a graph that did something like this, that would be an example of a velocity that is increasing. And the reason for that is we can see that from this secant to this secant, it is going up. So that's an increasing example. A case where you might just see a constant might be like this. Constant velocity. Notice if I take these 2 points right here, we see that we just have that same secant, or same value. Like here's another one that I can take. Again, same thing, same velocity. So this would be an example where the velocity is staying exactly the same. And that velocity is constant. The next one would be if we had something like this. That's where our velocity is not doing anything. You can even see that the slope of this thing is just 0. So that would be, that's not increasing or decreasing. The velocity is literally 0. And for the last one, if you saw a graph doing something like this, well, then that velocity would be decreasing. As you can see with the negative slope. So velocity is decreasing. So again, that was just kind of a recap and just to look at some of the different graphs and what their velocities actually look like from our 2.1 number 2 set of notes.